Alright, today we're learning 7-6, exponential growth and decay. The objective of these notes are so that you can solve problems involving exponential growth and exponential decay. So the first thing we need to understand is what is the formula that we're going to use for exponential growth. And we've got y equals a times the sum of 1 plus r raised to the t power. So let's go ahead and define what those variables represent. So looking first at y is the final amount. Okay, a is going to be your initial amount, kind of like your a sub 1. Okay, the r is your rate of change, the common ratio, and this is expressed as a decimal. And then your t is going to be time. So let's go ahead and get started with this formula to see how we're going to use it. So example 1, the prize for a radio station contest begins with a $100 gift card. Once a day, a name is announced. The person has 15 minutes to call, or the prize increases by 2.5% for the next day. So first we want to write an equation to represent the amount of the gift card in dollars after t days with no winners. So once again, our formula was y equals a times 1 plus r raised to the t power. So a is our initial amount. The initial amount for this is $100. That's how much, when the contest begins, how much the gift card is worth. So we're going to put 100 here. Times 1 plus, now remember our rate needs to be changed to a decimal. So right here we have it at 2.5%. Remember, to take 2.5% and change it to a decimal, all you do is take that 2.5% and divide it by 100, or move the decimal back 2 places, 1, 2, and we see that it's 0.025. So we've got 0.025, and t, they have not given us a time yet, so we're still going to use that as a t. And then right here, all we need to do is just add what's in the parentheses. So 100 times 1.025 raised to the t power. And there is our equation. Okay, now the next one says, how much will the gift card be worth if no one wins after 10 days? So now 10 days, they're telling us what our time is. So 10 days is going to be our t. So I'm going to take that formula that we have, y equals 100 times 1.025 raised to, instead of the t power, we're going to raise this to the 10th power. Okay, so now remember, we need to do our exponent first. So we need to take that 1.025 and raise it to the 10th power. This would be okay to do on your calculator. I would actually suggest you use your calculator for this. Okay, and we get some really long, crazy number. Okay, whenever you do that, go ahead and just after you get this number here, 1.025 raised to the 10th power, go ahead and after that multiply it by 100. And so we would say that this gift card is approximately, it's not a definite, but approximately $128. Okay? If you wanted to put some cents to it, it would be $128.01. And so there's our answer for that one. Okay, exponential growth, but using compound interest. So for this one, we have a different formula. So anytime you see compound interest, you're going to use this formula here. And let's go over what these variables represent. So the A is your current amount. The A is current amount. The P is your principal or initial amount. Okay, the T once again is going to be time. The R is your annual interest rate. And then the N's, and it would be the same for both of these, is the number of times the interest is compounded each year. So let's go ahead and look at an example of this so that we see how we can use this formula here. So example 2, it says Maria's parents invested $14,000 at 6% per year compounded monthly. How much money will there be in the account after 10 years? So let's go ahead and write down our formula. A equals P times 1 plus R divided by N raised to the N times T. Okay, so our initial amount, the amount that was invested, our principal, is $14,000. 1 plus our rate is 6%. So one more time, we have to take this and change it to a decimal. So that'd be 6 divided by 100, or move the decimal back 2 places and you get 0.06. Divided by, and N is how many times that was compounded per year. And we see that it was compounded monthly. Well, if it was compounded monthly, that means that is 12 times a year. So that's going to be 12 there, and then 12 times our time here is 10 years. So 12 times 10. So now we're just going to use our order of operations here. So we've got 14,000. And then first thing we're going to do is we're going to see what 0.06 divided by 12 is. And we get 0.005. And then 12 times 10 gives us 120. So we'll go ahead and do that. Now go ahead and add inside your parentheses 1.005 raised to the 120th power. So now in my calculator, I'm doing 1.005, and I'm going to raise that to the 120 power. And I get some crazy number. Okay, leave that crazy number into your calculator and multiply it by 14,000. Okay, and then go ahead and write your final answer down, and it should be 25,471 and approximately 55 cents. So that is approximately how much money would be in their account after those 10 years. All right, so now let's look at exponential decay. All right, so here's our formula, y equals a times 1 minus r raised to the t power. So this is just like exponential growth, except for instead of a plus, now we've got a minus. The y still represents the final amount, the a still represents the initial amount, the r is our rate. Remember, we need to change that to a decimal, and t is the time. All right, example 3. A fully inflated child's raft for a pool is losing 6.6% of its air every day. So that 6.6, that right there, is going to be our rate, our R. The raft originally contained 4,500 cubic inches of air. So originally, that means that's our initial amount. Okay, so that right there is our A. So let's go ahead and plug it into our formula. So we've got y equals a times 1 minus r raised to the t power. So that gives us y equals, our initial amount is 4,500. 1 minus our rate, remember we need to change that into a decimal because right now it is a percent. So you can divide it by 100 or move the decimal back 2 places, and that gives us 0.066 to the t power. So that gives us y equals 4,500. Go ahead and do 1 minus 0.066, and that gives us 0.934 raised to the t power. And there's our equation. So now the next question is saying estimate the amount of air in the raft after 7 days. So we're going to take that formula, and for t we're going to put 7. Now this is all calculator work right here. Put in your calculator 0.934, raise it to the 7th power, leave that number in your calculator, don't write it down, and then multiply it by the 4,500. And then we get y equals 2,790.23 if we were to round to the nearest hundredth. It says just to estimate, so I would be happy with just the 2,790. And there's your answer. And that would be cubic inches of air. So these are our notes for 7-6, exponential growth and decay. We will be working on more word problems tomorrow. If you have any questions, please let me know.